All right, welcome. It's Friday, July 31st, and today we're going to take a look at some more information on functions, and in particular, how to find a function's inverse. All right, the first thing we're going to look at before we get to inverses is understanding that there's two types of mappings that we're interested in. Okay, one mapping is known as a one-to-one mapping. And the second kind of mapping is known as a many-to-one. All right. Then we're going to identify or talk about the domain and the range of a function. So as you remember, hopefully, a domain are the numbers that go in, the input, and the range are the numbers that get generated or are the output. And then finally, how do you calculate the inverse of a function? So what an inverse does is it takes, if I had a function, it takes some x value and does something to it and turns it into a y value or an output. Well, the inverse, that's what a function does. The inverse does just the reverse. We write it as f with a -1 exponent x. That means the inverse. So the inverse takes the output and turns it back into the input. They undo each other. So examples of inverses that you've worked with in the past would be adding and subtracting. Those are inverses. Okay, when you solve an equation, let's say x plus 3 is 12, and you subtract 3 from both sides, you're using the additive inverse to solve that problem. Okay, an inverse in real life would be like turning on a water spigot. Turning it to the right, okay, turns the water off. Turning it to the left turns the water on. When you're putting a nut on a bolt, righty-tighty, lefty-loosey, those are the exact same thing. That's the same concept as an inverse. So if we take a look at the function f of x is equal to 3x minus 1. We can write it, this is another way of writing it. It means the exact same thing. Right? The way you interpret it is, when I read this, this just means that this is the name of the function, and it takes an x value, and it maps it onto 3x minus 1. That's exactly what this says. Now, if I wanted to find what's the value, let's say at 2, I'd put 2 in there for the x, and that's equal to 3 times 2 minus 1, that's 5. Well, in this notation, it would look like this. F, it's going to map 2 onto 3 times 2 minus 1 is equal to 5. Okay, they're just two different ways of saying the same thing. So what makes something a one-to-one map? All right, a one-to-one mapping. So the way to understand a one-to-one mapping is every value in the domain is mapped to a distinct value in the range. So what that means is, let's say you had the number 2, and it was mapped to the number 3 in the range. No other number in the domain would also go to 3. That's what the blue sentence means up there. Each value of the domain is mapped to a distinct value of the range. So no other number in the domain would get mapped to that 3. Another way to think about it is, if you start with the range, every element in the range, or number in the range, is mapped to exactly one value in the domain. Either one of these definitions explains what a one-to-one mapping is. Now let's take a look at it. What's that look like? All right, so here are the values that are in our domain. So these are just random, 4 random numbers. Okay, we're going to plug them into that formula. So when we plug in a 0, we get -1. plug in a 1, we get a 2. We plug in a 2, we get a 5. We plug in a 10, we get a 29. So now you can see how this definition works. Each value in the domain is mapped to this is the key word right here, a distinct value in the range. So no other numbers in this domain here are getting mapped to -1. Only 0 is. Or if you look at the red definition, every value in the domain or in the range is mapped exactly to just one value in the domain. That's a one-to-one mapping. Okay, we know our inputs are the domain, our outputs are the range. Okay, in this example, each x value maps to a distinct y value, and this is called a one-to-one mapping. All right, now let's take a look at a different kind of mapping known as a many-to-one. All right, here's our function, x squared minus 2x plus 3. Okay. We're going to take these inputs. So if we plugged a 0 in, it gets mapped to 3. If we plugged a 1 in, it gets mapped to 2. And then the question is this a one-to-one mapping? Okay, and let's see if it is. We're going to keep plugging in some numbers and see if any other numbers get mapped to either 2 or 3. So if I plug a 2 in, it also gets mapped to 3. So this now is known as a many-to-one. Okay. 0 is mapped to 3 and 2 is mapped to 3. It's no longer one-to-one. Or you can look at it from the range point of view. 3 is mapped to more than one element in the domain. So this is not a one-to-one function. Okay, there are some outputs. That's what this means right here. Some f of x values. Whoops. That is an output, which are generated by more than one x value. So 2 generates a 3, 0 generates a 3. This would now be a many-to-one function. And that's the difference between one-to-one and many-to-one. So here's another example of why it's many-to-one. These two values get mapped to the same value. So this is a many-to-one function. If we were to graph this, here's how you know it's many-to-one. Okay, this would be a parabola. If you draw a horizontal line, not a vertical line, but a horizontal line, and it touches the graph more than once, so it touches right here and right here, then it's automatically a many-to-one mapping. Okay. If it doesn't touch more than once, then it's automatically a one-to-one mapping. So for example, if I had a graph that looked like a cubic, and I drew a horizontal line, not a vertical, it only touches that graph once. So this, if we were to look at it, would be a one-to-one. This parabola would be an example of a many-to-one, because the horizontal line touches more than once. So that's another way you can tell what kind of mapping it is by looking at its graph. All right, So the summary is a function maps a set A inputs, we call that the domain, to a set B, the range, in such a way that each element in the domain maps to only one element or value or image in the range. Sometimes the numbers that are in the range are called the images of the numbers that were used to generate them. Okay, this means that one-to-one and many-to-one function or mappings are both functions. Now, when it's not a function is when you have something in the domain that maps to two elements in the range. So, for example, if I had, let's say, 0, 1, 2, those were my inputs, and then my outputs were, let's put a 4 in here too. 2, okay. If 4 went to a 2 and also got mapped to another number, let's say 3, that is not a function because this has two outputs. So there'll only ever be one arrow coming out of anything that is in the domain. Okay. So this would be a function if all of these went to the same value. This is a many-to-one function. Okay, so to clarify this, this first example here is not a function. Okay, because the 2 is associated with more than one number in the range. Okay, and that is not allowed to happen. Okay, so, whoa. Okay. Easy there, buckaroo. Let's see, let's erase that. There we go. So this 2 has more than one number associated with it. Not a function. Now, if you look at these, the number of arrows coming out of each number in the domain is exactly 1. Now, 1 gets mapped to 5 and 2 gets mapped to 5. That's okay. All right, this would be a many-to-one function. So this is a function. This is a one-to-one function, whereas 2 gets mapped to 4 and no other numbers get mapped to 4. 0 gets mapped to 6, no other numbers get mapped to 6. On our many-to-one, 1 gets mapped to 5 and 2 gets mapped to 5. These last two are still functions. One is called a many-to-one and the last one is called a one-to-one. Alright, so this next question is asking us to find the A and B constants and then to determine, is this, what type of function is it? So is it many-to-one or one-to-one? All right, so you did something similar to this in your assignment from yesterday. Function g is defined as taking x and mapping it onto ax squared plus b, where a and b are constants. That means they're numbers. Okay, to find the value of a and b, you're going to take these values and substitute them in. Okay, so this is your x value, and this is the corresponding y value. So I can take this right here, and I can write it as, just think of it as a function. F of x is equal to ax squared. This is how we're used to writing them out. Okay, this is the same as y equals ax squared plus b. All right, now what I'm going to do is I'm going to substitute in I'm going to put 3 for x and 23 for y and see if I can get this down to just one variable. So let's see, that's 23. Okay, this is going to be a times 3 squared plus b. Okay, I can't do anything right here because I have two unknowns. I still have an a and a b. Okay, now let's try it with the other set of numbers and see what we get. So now I'm going to put in x is -2 and y is 8. So I get y is 8, and then I'm going to have a times -2 squared plus b. So I get 8 equals 4a plus b. So now I've got two equations. And I still have two unknowns. So I don't know what a and b are yet. Well, if you remember, when you have more than one variable, one way to solve them is to use simultaneous equations. Set up a system of simultaneous equations and then solve it. So let's go ahead and do that. Alright, I took my two equations and I just rewrote the variables. I just switched them around because we're used to the variables on the left side. Okay, now what I'm going to do is ask myself, what could I multiply one of these equations by so that when I add them, I get one of the variables gets eliminated when I add these two. Okay, so for example, if I took the top equation and multiplied it by -1, the b's I'd have minus b plus b would cancel. Or if I did the same thing to the bottom one, they would cancel. All right, I'm going to do it to the bottom one because I want the, let's get this out of the way. There we go. Let me rewrite this. Hold on a second. All right, so I chose to take the bottom one and multiply it by -1. So I'll have 23 plus -8, and it's a positive number. So my top equation doesn't change. It stays 9a plus b, 23. My bottom equation now becomes -4a minus b equals -8. Now I'm going to add those two equations up, and I get 5a. The b's cancel, and I get 23 plus 8. Which is 15. Divide by 5, and I get my value of a, which is equal to 3. So now I know my a value. I can plug it into either one of these equations and get my b value. So if I took the bottom equation, 4 times a, that'd be 4 times 3, plus b is equal to 8. B is equal to 4. And there's my a value and my b value. All right, so now we got a and b. A is 3, b is 4. So our function g is going to be 3 x squared plus 4. Okay, because we got a was 3 and b was 4. So this is going to be 3x squared plus 4. All right, so we got our a's and b's. Now it says, what type of function is this? Okay, now I'll show you the shortcut. In your head, think, what shape is this? All right, well, this is a squared term, so this is going to be a parabola. since the 3 is positive, this parabola opens up. So I showed you in the previous slide that if you did a horizontal line and it touches more than once, there's a horizontal line, it touches right there and it touches right there, okay? Horizontal line touches more than once, then it is a many to one. So this is a many to one. Now we could also start to plug numbers in and see if we get a y value that repeats. Okay, so many to one is going to tell us we've got a repeating y value. Okay, let me get rid of all this other stuff here so we can see. There we go. Okay, so there's our a's and our b's. And then it says what kind of function. So you can try some values. And right there, that shows you that this is a many to one. If we were to take these as ordered pairs, the y value, you'd have a repeating y value. 1 in the x gets paired with -1 in the y. -1 in the x gets also paired with number 1 in the y. This is many to one. Okay, these two numbers are getting mapped to the same numbers. So another way to think about a many to one is if you have any y values that repeat, it's many to one. It's 1 to 1 if no y values repeat. That's a real simple way to think about it. All right, the last two sections here have to do with how to find the inverse of a function. All right, so to find the inverse of a function, okay, if we take some values here, all right, so 2 gets mapped to 8, 5 gets mapped to 17, -3 gets mapped to -7. Okay, looking at this right now, this would be a 1 to 1 function. Okay, the inverse function undoes the function. It takes the values back again. So that's what happens. In the inverse function, notice the range now became the domain, and the domain now became the range. Okay, so here it was before. This is the original function, and then what the inverse does is just switch them, and my arrows go back the other way. That's what an inverse is. Okay, to find the inverse, okay, what we're going to do is we're going to take this function and we're going to write it as 3x plus 2. Okay, we took this right here. All right, now what we're going to do is rearrange it so x is the subject. Okay, the way that we say that is solve for x. So I'm going to take this, get x all by itself. So I subtracted 2 from both sides, and then I divided everything by 3. Okay, now x is the subject. X is by itself. Now what you're going to do is you're going to switch x and y. Okay, you're going to flip them just like we did up here. and that's your inverse. Okay, so when I switch these, this became, wherever there was an x and a y, I just reversed their places. So the y came out here. This is y equals, the x went where the y is. And then to show that this is the inverse of the function, instead of using y, I use the inverse notation, which is f negative 1 of x. Okay, that means the inverse. Okay, now you can check if two functions are inverses. Okay. If I plug a 1 or 2 in, an 8, when I put 8 into this function, 8 minus 2, okay, I get 6. 6 divided by 3, that gives me 2. Eight maps back to 2. If I take 17 and plug it into the inverse, it takes me back to 5. And if I take negative 7 into the inverse, it takes me back to negative 3. That's what inverses do. The values are taken back. Okay, the last section is find the inverse of each one of these functions. So I'm going to pause the video and go through each one and see if you can find the inverse. Your steps are: 1, rewrite the function so that x is by itself. Solve for x. Then switch x and y. Okay, I'm going to pause and then we'll come back and see how you did. All right, our first equation. So I'm going to rewrite this as y equals 1/2 x minus 4. And I'm going to solve it for x. So I'm going to add 4 to both sides. And to undo multiplying by 1/2, I'm going to multiply this side by 2 over 1, or just 2, and this side by the same thing. These cancel out, and on the right side I've got x, and on the left side I've got 2y plus 8. And then my last step is switch x and y. Okay, so I'm going to end up with 2x plus 8 equals y. That's the inverse. Now the way that we write it is, we take out the y and we put in the notation for a function. Well, yeah, this was f equals 2x plus 8. All right, I want to solve this for x, and then when I'm done with that, I'm going to switch x and y. So to get this x out of the denominator, I'm just going to turn this into a proportion. A proportion is just 2 equal fractions, okay, or 2 equal ratios. So over here on the left, this is really the same as y over 1. Now I know that one of the properties of a proportion is that the cross products are going to be equal. Okay, so the cross product on the right is 4 times 1, and then the cross product on the left is y times 2x minus 1. Now my goal here is to get the x by itself. All right, so I got to undo what's happening to the x here. So if I multiply through with the y, so I got 2xy minus y is equal to 4. All right, now I'm going to start to get this x by itself. I'm going to add y to both sides. And I have 2xy equals 4 plus y. Now I can divide both sides by 2y. And I have x all by itself. Okay, then we're going to switch x and y. And there's our inverse. Instead of writing y, we write the inverse notation. And there's number. Okay, solve for x. So I'm going to use the same strategy I did on the previous one. I'm going to turn it into proportion and cross multiply. So I got 3y on the left, and then I got 1 times 4x minus 1. All right, I want to get x all alone. So if I divide both sides by 4, that strips that away, and I'm left with x minus 1 equals 3/4 y, and now add 1 to both sides. And I have x equals 3/4 y, okay, plus 1. And now switch x and y. And there's our solution. Okay, what I want to show you up here is on this step, had you distributed, you'd still get the same answer. So we're trying to solve for y, or excuse me, we want to solve for x. So that would be 4x minus 4. So now I would add 4 to both sides. Then I would divide everything by 4, and I get 3y plus 4 over 4. Okay, these are the exact same thing. See, if I took this and wrote it as 3y over 4 plus 4 over 4 equals x, that's the same as 3/4 y plus 1. So it wouldn't matter which way you did it. All right, my first step, get this out of the denominator so I don't have any more fractions in here. That's the same as multiplying both sides by x plus 3, or turning it into proportion and cross multiplying. So I got x plus 3 times the y value on the left, and then 1 times x minus 1 on the right. Now I'm going to distribute and get rid of my brackets or my parentheses here. Move all the x terms to one side. So I want to get x's on one side, numbers on the other. Okay, all the other terms to the right or to the left, so I'm going to add 1. Now I can get the x all by itself by factoring out these have a common x. And then I'm going to divide both sides by 1 minus y. Then switch x and y. So instead of writing y, I'm just going to write this. And that's my notation for the inverse. And then wherever there's a y, I'm going to put in an x. And there is how you find the inverse. All right, so for your assignment, this will be due, let's see, today's Friday, Saturday, Sunday evening by midnight. Okay, have a great weekend, and I will see you next time.